Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 8 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1751, maximum number of events that can be attended to. Let's read the problem statement first. You are given an array of events where events of I is equal to start day, end day and value. Okay, the ith event starts at the start day and ends at the end day, and if you attend this event you will receive a value of I. Okay, so that's the meaning of this events of I. You are also given an integer k which represents the maximum number of events you can attend. Okay, you can only attend one event at a time. If you choose to attend an event, you must attend the entire event. Okay, so if this event is starting on day 1 and ending on day 3, right? So if I plan to attend this event, so I should be there for whole event, okay, from day 1 to day 3, right? So if you choose to attend an event, you must attend the entire event. Okay, note that the end day is inclusive. Okay, day 1 to day 3. All right, that is, you cannot attend two events where one of them starts and the other ends on the same day. Okay, so it means that, let's suppose this is event A, okay, and there is one more event B. Okay, this, let's say this is event B. So event B is also starting on day 3, and let's suppose it is going until 6. Okay, so note that the end day is inclusive. That is, you cannot attend two events where one of them starts and the other ends on the same day, right? So I can't attend. Okay, if I'm attending event A, then I can't attend this event 2. Okay, so if I'm attending this event B, then I can't attend this event A. Okay, because if you see these two events, they are, one is starting and one is ending on the same day. Okay, we have to return the maximum sum of values that you can receive by attending events. All right, clear? So now let's see some examples here. Example number 1 to 2. Okay, day 1 to 2, 4, right? So here's the time 1 2. Okay, this event, let's say event 0. Okay, let's say this is event 1, this is event 2. Okay, so event 0, 3 to 4. Okay, here event 1, 2 to 3, 2 3, event 2. Okay, now if you see, I can attend this event, okay, day 1 to 2, and this event 1 is starting on day 3 to 4. Okay, so I can attend these two, right, without any issues, right? So total sum that I'm going to get is 4 plus 3, 7. Okay, same way I can attend just event 2 also, but in this I'm just going to get one sum, right? That is not good output, right? We need maximum sum of values. So I'm going to attend event 0 and event 2, and I'm going to get my sum value as 7. Okay, so you have to choose the green events 0 and 1. Okay, 0 and next for a total value of 4 plus 3, 7. All right, now if you see this example number 2, so 1 to 2, okay, then 3 to 4. Okay, I can attend these two, 4 plus 3. Okay, this is one way. Then I'm going to get sum 7. Or I can do one thing now, I can simply attend this event. Okay, then I'm going to get sum as 10. So this 10 is going to be my output. Clear? So choose event 2 for a total value of 10. Notice that you cannot attend any other event as they overlap, and that you do not have to attend k events. Okay, right? So it is not mandatory to join k events. Okay, so you are also given an integer k which represents the maximum number of events you can attend. Okay, so it's not like we have to attend these two. Okay, right? So that's why I explained this example. Okay, so you can't attend any other event as they overlap, and that you do not have to attend the k events. Okay, clear? Now see this example number 3. So here you are going to say that 1 1, okay, 2 2, 3 3, 4 4. You are going to say that we can attend all the events, right? 4 5 5 6 7 8 9 10, but 10 is not output. Output is 9, right? Why? Because k is 3. Okay, so although the events do not overlap, you can only attend 3 events. Okay, so we have to pick the highest valued. So highest value 3, highest valued are 4 3 and 2. So 4 plus 3, 7, 7 plus 2, 9. Okay, this is my output, and these are the constants for this one. Okay, so now let's understand this problem with this first example only, right? So here see, let's say this is event 0, event 1, event 2. Okay, so event 1 you are attending. Okay, 1 to 2 you are going to get 4. The next time 3 to 4, yeah, we can attend 3 to 4. Let's attend this 3 to 4. Event 1. Okay, this is nothing but event 0. For this sum is 3. Okay, next time you reach here 2 to 3. Okay, so now this event 2 is starting on this time, okay, 2, but this we should have seen this in the past, right? Because I already moved first move 1 to 2 and then I moved to 3 to 4. Okay, so this is the event that is already occurred in the past. Okay, so this problem is a little bit like interval based, right? 1 2 3. Okay, so we can do one thing, we can do the sorting on them. Okay, so based on their start time we can do the sorting. Okay, so I don't want to see this event which happened in the past in later point of time. Okay, I want to see them in the beginning only, right? So if I sort them, so what will happen? So first I'm going to write this 1 2 and 4. Okay, this is event 0. Then I'm going to write this 2 3 and 1. This is my event 2, and then I'm going to see this 3 4 and 3. Okay, this is nothing but event 1. So now if you see, now it is easy for me, right? Because I have just sorted them based on the start time, so I can check, okay, side by side. So here event 0. Okay, so let's say I'm starting from here. If I take this event 0, then that means 1 to 2, and I am going to earn 4. Okay, if I'm planning to attend this. Okay, take this. Okay, take this event. Now here, let's if I take this event. Okay, if I take this event, so here if you see, next time this event is starting from 2. Okay, but I don't want. Okay, so if this event is ending at 2, okay, and I'm taking it, right? So next event that I can take is going to be this one, because this is starting from 3. Okay, this is inclusive, so I can't take any other event which is starting on the same day. Okay, so I can simply move further now, right, like this, and whatever the first I will find, I will just place that. Okay, but that is not possible here, right? Here I'm going to take this and this, then I will find again something, some event which happened in the past. Okay, so I don't want that. Okay, so here if I take this 1 2 4, then next time I can only take this event. Okay, that is nothing but 3 4 and 3. I can take this. Okay, this is one way, right? So if I take this, then next time I can only take this. Okay, and if I take this, uh, and after that I can't take this. Okay, this is not in the option, right, in this side. And if I don't take this also, then that's it. Okay, so here this is nothing but a type of a recursion tree that I'm drawing, right? So from here 4 and from here 3, you're going to get total value here in the top 7, let's say. Okay, same way, let's suppose here in the beginning you skip this. Okay, you skip this, so next time uh you skip this, so next time you are left with this 2 3 1. Okay, and this 3 4 3 in your recursion tree. Okay, so now again you have two options. Okay, you can take this or skip this. So if you take this, you are going to get 2 3 1. Okay, now if you take this, then next time you can't take this. Okay, you can't take this because this is starting on 3 and this is ending on 3. Okay, so you can't take this anything, right? There is no other event. So from this side you are only going to get 1. Okay, one value. Okay, 1, and here 0. Now here you can take anything, right? And here you have just this 3 4 3. Okay, so if you skip this, if you skip this also, then you have just one option. So here also you have two options, whether you can want to take it or not. So if you take it, you are going to get 3 4 3. Okay, if you skip it, then you are going to get nothing. So here, from here, you are going to return just 3. Okay, so this is nothing but your recursion tree, right? So we have two options every time, take or skip. Okay, so if I am taking this event, right, then next time I'm going to pick those events only where the start time is greater than the end time of the previous one. Okay, if I'm taking this, if I'm skipping this, then next time my eye is going to move, it's going to start searching from here. Okay, so that's what we need to do, right? Very simple. Okay, so here I am searching, right? After this 2, I'm searching for the other event, and since this array is already sorted based on their start time, I can directly apply the binary search also. So how does my binary search work? So let's suppose you have n number of events. Okay, n number of events. Okay, total number of events. In this case, 3 events are there, 1 2 3. Okay, so that's why you have n number of events. Okay, so you have already sorted them based on the start time. Okay, so let's suppose you are searching for the start time 7. Okay, so first this is your range. Okay, you are going to get some mid. Okay, let's suppose this is your mid. So now let's suppose your 7 value lies somewhere here. Okay, then next time what you are going to do, since you have already sorted now, so next time this is your low, this is your high in the starting. Okay, and this is mid. So next time you are going to operate your low as this value mid plus 1. Okay, mid plus 1, and keep high here. Okay, so let's say you are going to get somewhere here. Okay, this as your mid. Okay, so now if you see, your 7 lies here, somewhere here. So what you are going to do in binary search, so then you are going to take you're not going to change your low. Okay, low is still m plus 1 here, this previous one, and you are going to update your high as this value, okay, mid. Okay, so high is nothing but mid. Now again you are going to find out. Okay, so in this way you are going to do the apply the binary search on the answer, okay, whatever the value that you are searching for. Okay, and you will get the get that particular event. Okay, so we will apply the binary search on this. Okay, so binary search is very easy, we have applied this many times. Okay, but here this is important that we can do the take and skip. Okay, and this take and skip is only possible because we have sorted the array. Okay, and binary search is also possible because we have sorted this array based on the start time. Okay, done, right? Okay, so let's write the code. Very simple, nothing complex here. Okay, so first thing, here what you need to do, uh, first let's do the sorting. Okay, so here I'm just going to write arrays dot sort. What we need to sort, we have to sort the events. Okay, and how I'm going to sort the events, based on the start time. Okay, so let's suppose we have two parameters, a and b. Okay, so here what I'm going to compare, I'm going to compare the value at 0 index. Okay, so here I'm writing integer dot compare, and here inside this a0, and here I'm just going to write b0. That's it. Okay, this is done. So this is going to sort by start day, right? And let's calculate the total number of events. So here you can simply write events dot length. All right, and from here what I'm going to return, I'm going to call one method. Okay, let's say dfs. Okay, in this dfs I'm just going to pass my starting index 0. Okay, and I'm going to pass how many total events that I can take. Okay, so k events. Okay, so remaining events, right? And here I'm just going to pass the my events array. That's it. Okay, this is what I'm going to pass. All right, okay, so here if you see in this recursion tree diagram that I've created, so if here let's suppose k is equal to 2, right? So if I'm taking this, so my k value will be decremented. Okay, k value is going to become 1. All right, okay, if I'm taking this, next time I take this, so my k becomes 0, so I have to stop. Okay, I have to return the answer from here, right? So here in this side, if I skip this, then still my k is equal to 2. Okay, and these are the events that are left. Okay, then from these events I have the options. Okay, 2 3 1 and 3 4 3. Okay, so this is okay what we need to do, right? So here if I'm taking this, now my k is going to become 1. Okay, then from here there is nothing else we can pick, so we are just going to get 1 here. Okay, because it is not mandated to attend k events, but max limit is there that we can attend at max k. Okay, so that is why I'm passing 0 k and events. All right, now let's write the method for this dfs. So here private int dfs, and here inside this we are just going to pass the index, we are just going to pass the remaining events. Okay, and we are just going to pass the our events array. Okay, events, done. So here few base conditions that we have to write. So if my index, okay, it becomes equal to events.length, events.length, that simply means that we have checked all the events. Okay, this happens, or my remaining becomes equal to 0, then we have to stop now, right? Remaining is equal to 0. Okay, so in that case we have to stop. Okay, so from here I'm just going to simply return 0. That's it. Okay, right, then I don't need to return anything. Okay, just simply return 0. Okay, and here we have two options, right? Skip the current event. Okay, so if I'm skipping it, then what will happen? So int skip. So in case of speak this skip, right, so dfs same method I'm going to call, but this time my index is going to be incremented, index plus 1. Okay, if I'm skipping, right, remaining will remain same, remaining will remain same, and events will remain same. Okay, same array. Okay, so this is my option 1, that is skip. Okay, now option 2. Okay, so here skip current event, done. Okay, so now if I plan to take this, okay, attend the current event, so in that case the next index, okay, if I'm planning to take the current event, so my next index is going to become, okay, next index also we need to find, right? So for that I'm going to write the binary search. Okay, so final find next. Okay, let's say find next. Okay, so in this case what I'm going to do, so find next, I have to search in the events only, events array which is already sorted, right? And this, okay, you can say, and we have to pass the this if I'm taking this now, so this is the end time for this. Okay, so I have to find out the upper value than this. Okay, bigger value. Okay, this is 2, so I'm searching for 3. Okay, next event which is starting from 3. Okay, so let's pass this value, right? So here I'm just going to write events, let's say end day I'm passing. Okay, I will create the one variable name end day. Okay, so index and 1. Okay, in this method, right? So this is done. Okay, next index, this is how I'm going to search, and I'm talking about take. Okay, so if I'm taking it, so if I'm taking this, again we have to call this only, right? But here my next index. Okay, I'm going to search from here. Okay, so here I'm just going to find update this next index. Remaining, if I'm taking that, right, so remaining will be decremented. Okay, so remaining -1, and here events. So here this is nothing but option number 2, that is take current event. Okay, done. And that's it. Okay, so from here you have to just return whatever the max value. Okay, so math dot max, whatever the max value you are going to take from that, whatever the max value that comes from this skip and take. Okay, so we have two sides, right? This is my recursion tree diagram. Okay, starting from here, so we are going to get some value from this side, from this side. Okay, so whatever the max value, okay, take and skip. Okay, whatever the max value that I'm going to get. So here I'm going to write skip take. That's it. Okay, done. And now let's write the code for the uh, this is a binary search. Okay, so private int find next. Okay, so what we are passing, in this method, one is our events array, and we are passing the end day. Okay, so here I'm just going to write end day. Okay, these two things back we are passing. So now this is very simple. Okay, so we have to search over all the events, right? So low is 0, and here high. Okay, high is equal to events dot length, right? So here simple while low is less than high. Okay, so here what you are going to write, mid you have to calculate first. Okay, so int mid is equal to low plus, and here high minus low divided by 2. Okay, and here if events start time, okay, mid and 0. Okay, so mid 0, okay, start value is greater than end day. Okay, so that simply means that I'm getting some event which is having the bigger value than the end day. Okay, I'm just going to write high is equal to mid, right? And else, okay, if this is not the case, then in that case what you need to do, you have to just simply put your low as mid plus 1. Okay, mid plus 1. Okay, so now from here you have to simply return low. That's it. Okay, so here this ends. Okay, so now let's try to run it. Okay, so there's some issue here. It should be events. So there are some issues. Okay, so let's try to fix that. If I'm taking this, okay, if I'm taking the event, this event, then next time I have other options, right? I have to search here, but I have to add this event value also now, which is 4, right? So here I missed that part. Okay, so here I'm just going to write events index, and here you have to pass 2. Okay, that's why. So now let's run it again. Okay, so all the test cases has been accepted, right? So now let's see if we are able to submit this solution or not, or we are going to get time limit exceeded error. Let's see. So see, we are getting time limit exceeded error, right, in this test case. Okay, so reason is, in the, if you see here what we are taking, we are searching on this, okay, DFS index and remaining. Okay, index and remaining. Okay, so here there may be some case where we are like, there is one tree, right? Let's suppose this is one tree. From here skip, take, from here skip and take, from here skip and take, from here skip and take. Okay, let's suppose this is one tree diagram. Okay, skip and take, skip and take. So here maybe let's suppose maybe there is remaining events is 2. Okay, and you are at index, let's suppose 4. Okay, and somewhere here also this is the same case. Okay, you are at index 4 and still the remaining index at 2. Okay, so this happens now. Like, let's suppose here you choose event A, and here in this side you choose event C, D, E. Okay, these events. Okay, and here you, let's suppose you have chosen A, B, or Z, some events. Okay, but again still if you reach this side and reach this side, there's still the same case. Okay, so number of events, you are at index 4 and 2 you have to choose. Okay, you, again here also, so you are calculating again tree diagram for this. Okay, again tree diagram for this. So I can do this, I can store the result of this. Okay, whatever the best result that I'm going to get for this scenario, I will store that, and if the same case arise somewhere else, I'm going to simply return the value. Okay, so I'm going to apply the memoization part, right? So that is also very simple memoization part. Okay, just a few lines of code. So here create one memo array, memo. Okay, done. And here initially let's do one thing. We are just going to fill all the values with -1. Okay, that simply means that we haven't seen that result before. Okay, so first let's initialize it. New int. Okay, so total number of events. Okay, I'm storing the index, right? So total number of events, and here how many remaining. Okay, so until like if value is 6, so 6 events we have to choose, right? So 6 is inclusive, right? So I'm going to write k plus 1 here. That's the reason. Okay, and here just iterate over all the rows in this memo 2D array. Okay, so int row in memo. All right, and here just going to fill arrays dot fill all the rows with -1 value. Okay, -1. This is done, right? And once this is done, okay, so here one more base condition I have to check. If I haven't seen the result in the past, okay, memo index remaining. Okay, only these values are changing every time, right? Remaining. Okay, so if this value is not equal to -1, okay, so just before doing this skip and take, I will check if this value is not equal to -1, then that means for the when this was the index and when this was the remaining, I have already seen that particular, I have already solved that particular tree. Okay, I have already seen that value, right? So if that value is not equal to -1, so I'm just going to simply return what, memo index and remaining. Okay, right? And if I haven't seen it, I am going to solve this. Okay, and here whatever the result from this skip and take, okay, I'm just going to store this in memo of index of remaining. Okay, that's it, that's it. Now let's run it and let's see. So here okay, here int n. Okay, so n I'm defining here now. So let's do one thing now. Let's do one thing here. N is pretty much to copy this, paste it here. That's it. Okay, now let's run it again. Okay, so all the test cases has been accepted. Now let's see if we are able to submit the solution. So see, our solution is accepted now, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.